Good day to everyone. So I am back. So I hope that from my previous videos, marami po tayong natutunan. This is a educational purposes for studying foundation engineering and also geotechnical engineering. So by the way, this is Edward Achansa. I am a practicing civil engineer in the Philippines, and I am having a further study of geotechnical engineering or foundation engineering. So here, on my next video, magkakameron tayo dito ng pag-prepare ng earth pressure na meron tayong profiling since we have 1, 2, 3, 4, 5, 6 levels of soil. Then, paano natin ito gagawin na magkakameron tayo ng profile? So, there will be a tabulated values para dun sa makukuha natin every layer, and at the same time we are going to use a software para magkameron tayo ng more better understanding, and at the same time realization that the calculation that we are using is correct, and mas may kumpiyansa tayo doon sa mga design natin. So okay, let's try to start. Let's go first to our first problem. So the problem that I'm going to have here, it will be from the book of Robert Boyles. So I am using Foundation Analysis and Design 5th edition of Robert Boyles for our problem. So which is found on example 11-5. So since we have if we have already our if we have already our copy of the book, then maybe we can use it to further develop our structural engineering. So I have a snapshot here. So this is the problem. So example 11.5. Then I have also make a tabulated formulas, and and at the same time the soil properties of every level para mas madali nating maiintindihan. So here, plot the active earth pressure diagram and compute the resultant R and its location Y bar for the wall system shown in figure E11-5. So E11-5 is this one, as what you can see. So we have the soil properties on every level, and at the same time the forces uh, that we are going to compute as per the earth pressure. All right. So next, if we're going to look at my Excel file, I have here the tabulated value for the soil profile on every layer. Then I have already tabulated. This is with calculated as per on the calculation of Robert Boyles. So these are all the soil pressure. Then next, we have here the values of the wall pressure, then every forces on every level, then the moment arm, then this will be our moments. Then we can have our resultant value and also the resultant moment arm. Okay. So if we're going to have a better understanding, let's try to work out on our software. Then the software that I'm going to use here is Geo5. So here, let's try to open up my Geo5 software. Up, up. Okay, all right. So now on my Geo5 software, we can see, let's try to open it up. So the first, you can download this on its software on its site, but it's only a demo version. But even if it is a demo version, we can learn how to use it. And the only problem is there will be a watermark of a demo version, and we cannot save and we cannot print it. But on in the purpose of studying and understanding the geotechnical engineering, then this is a good software to use. Okay, so the first thing that we have to do is go to the project tab. Then the first thing that we need to type here is the task, which is soil profile, as per our example. Then description, example number 4. Then the author. Then next is our setting. The setting will be the analysis na gagamitin by the software. Then next tab will be the geometry. So the geometry will be the height of our soil profile, or height of our trench or excavated soil. So on our example from Robert Boyles, it is 9.1 mm, but this should be in meters. Pag ginawa nating mm, hindi lalabas yung uh, forces that is calculated on the book, and at the same time, even if we try to make a manual calculation, mahirapan tayo. So, hindi pa rin lalabas yan. Then next is meron tayo dito na profile. So here on the profile, all we have to do is we need to add it. Then once we add, so meron ditong nakalagay na nakikita ba yung ano? So di pa nakikita yung output. Let's try to show the output. Output. Hindi nalabas yung output natin. Wait lang. Palabasin natin yung output. Okay. Alright. Also, ito na yung output natin. So, meron tayong, I will try to pick the first one. So, the first thing that we need to do is tick that thickness layer. Then, ito na lang yung palitan natin. So, let's try to put 1.8 para hindi na tayo magko-compute kung ano yung pagkakasunod-sunod or what is the because if we're going to use the depth, magkakameron pa tayo ng iisipin pa natin kung ano yung depth interface niya, kung ano siya. So, medyo magko-compute pa tayo. So, parang ma-lessen natin yung any kind of calculation. So, yung thickness na lamang. Then, once you click the add again, lalabas naman yung sunod na layer. So, that will be number 2. Okay, then, let's try to tick the layer. Then, 0.6. Then, next. Sunod naman is 2.75. Then, next is 2.45. Then, the last one, it will be 1.5. So, ito yung pinaka na nasa ibaba. Then, we still have the total of 9.1 of the height of the it's either a trench or excavated soil. This will be our depth of our soil. Okay. So, next is we need to go to the soil itself. So, ngayon, here on the soil, so all you have to do is click this add. Then, once we click the add, so we have properties that we needed to write on our soil. So, the naming that I am using is kung ano yung level niya para mas madali tayong mag-designate ng once we are on the assigning of the soil. This will be on the next tab. So, on our first soil is meron tayong what is our unit weight? It will be 17.30 kilonewton per cubic meter. Then, angle of internal friction. Ano ba yung angle of internal friction? 32. Then, may cohesion ba tayo doon sa first layer? Wala tayong cohesion, so 0. Then, angle of friction structural soil. So, gagawin natin pong 0 dahil wala naman tayong any kind of concrete structure. So, 0 lamang siya. Pero if meron tayong retaining wall, so that will be another way kung paano natin lalagyan ng angle of friction para dun sa structure. Then, the saturated will be 17.13, so it's still the same. Then, next is yung 0.6. So, S 0.6, then, kung titingnan natin sa, oops, okay, sorry, nawala. Okay, sa 0.6, meron tayong unit weight na ilalagay. So, ang unit weight na gagamitin natin is 9.79 because this is the unit weight of the soil itself na hindi kasama kasi there is already the groundwater table. Then, ano yung angle of internal friction? It will be 0. The cohesion will be 70. Then, no retaining wall or no concrete structure, kaya 0. Then, the saturated unit weight will be 19.6 as per unit weight na nasa problem natin. Alright. The next is S275. So, on the layer ng 275 is our unit weight is 9.89 as per uh, on our problem. Then, angle of internal friction will be 10. Then, cohesion is 30 kPa. Angle of friction structure is 0. Then, saturated unit weight is 19.70. Alright. So, it's the same thing na gagamitin natin sa 2.45 and also for the last part which is 1.5. Then, next is we have to assign the soil. So, ito na yung sinasabi ko para mas madali nating ma-assign yung soil properties nila. So, all we have to do since I have already named it as per the height, so we're just going to choose respectively. So, 1.8, S06, 275, 245, then 1.5, then the last one will be the 1.5. Then next is we'll go to the terrain. So, flat lamang naman yung ibabaw. So, okay na siya. Wala na tayong babaguhin. Then here, groundwater behind construction. So, on the given problem, we have 1.8. Simula na yung groundwater table. So, the groundwater table, gagawin natin 1.8 on this part. Then next, the surcharge. Okay. Then, here, just try to click add. Then, wait lang po. Okay. Then, this is the outbox na makikita natin. So, all we have to do, para mas madali pa rin yung, yung ating designation of the names. So, S100 ang ginawa ko dito. S100, then surface, permanent, then ito na yung lalagay natin na 100 for the surcharge. Then add, okay. So ito na yung surcharge natin. Then earthquake, wala naman tayong i-consider na earthquake. As of now, leave it by. Then stage setting, leave it by. We don't have anything na i-set pa muna. Then next is the analysis. Now, on our analysis, makikita natin dito yung mga values that have been prepared by our software. Then, I will try to open up with the dito sa example natin. So, makikita natin na halos parang magkaiba ata yung mga values natin. Pero, it's hindi naman siya talaga magkaiba. Dahil dito sa GU5, the total resultant na makukuha natin dito is the combination of the water and also for the soil. So, dito kasi pinaghiwalay niya yung value. So, to better have an understanding on this one, so, let's go back to my Excel table. Okay, Excel table para mas makita natin. So here on my Excel table, makikita natin na alright. So merong ang overall force natin is 813.38. So kung mapapansin natin dito sa lower portion na to, ito na yung total force ko na magkasama yung soil pressure and at the same time yung water water pressure. So almost the same na siya. 810 yung manual calculation and ang lumabas naman kay J5 is 813.38. So almost equal. Then yung depth of centroid is 5.83 dito. On my table, it's also 5.82. Ano tong 5.82? So, naririto na yung overall moment ko, overturning moment ko, and at the same time, the overall forces. So, I'm just going to divide the overall, the OT by the force. So, ito yung lalabas ko ngayon na, uh, no, lalabas ko dito sa value na 3.28. So, itong 5.81 is ima-minus ko pa siya dito sa total height na 9.1 para makuha ko yung overall na centroid na pamula doon sa bottom of the soil. Dito sa bottom of the soil going up, so yun yung 5.83. Kaya almost the same pa rin yung mga nakukuha na value. Then, if we're going to look on the forces, at active pressure is 35.73. Then, meron tayong water pressure na 266.45. So, kung pupunta tayo dito sa Excel file, this is 108. So, meron tayo na ito yung 263 para do sa water pressure, 266.45 pero doon sa calculation na manual is 261.39, so almost the same. And ito yung total forces na 548.61 and 511.20. So maybe the discrepancy here is that yung ang ginamit ko kasi na value for the water is 9.801. So, kaya siguro magkaiba is iba yung ginagamit ni J5 pero in the overall naman, the value that we are requiring is almost the same. From the depth of the centroid is almost the same as with J5. Then the total pressure is almost the same as the total pressure dito sa J5, 810 against 113, and the same thing with the forces. The forces na nakuha natin. So this is the how we are using or having a better understanding on our profiling for the soil with different level. So I hope na meron po tayong natutunan dito, and I will have more videos. So if you have any kind of topics na gusto pag-aralan, then we can verify it with the software. Then mas magandang better learning para sa ating lahat yun. So dito na lang po. Good day to everyone.